beer and fizzy water in the fridge, but I'm letting it cool. So as soon as we're ready, we'll go get it.
It's not recording yet, by the way.
Yeah, I know. Yeah. No, we're not scheduled to start the actual talk until 7 anyways.
Do you know why does it show like that it's scheduled at like 5:55 instead of like 7?
Yeah, I don't know. I guess it's just the way they're doing it these days. So yeah. We have to be out of here by like everything back to normal by 9. So that's why we say it's done at 8:30. Am I gonna fill an hour and a half with what I've got? No, I'm not. But we may actually fill the entire hour and a half with conversation though. So that's the ideal anyways. Yeah, I do not do Go for my day job at the moment. Like I sometimes work with Go code, but like that is I'm not. Back when he and I worked on the same team, like we were writing Go code every single day. I haven't done that in a while.
Oh, what language do you use? What do you do?
Kind of a mix. You know, every once in a while I'll jump in and fix some Go code or something, but more often I am subjected to Python or I know a lot of people would complain about using shell scripts, but you can make shell scripts that don't suck.
You use ZSH.
No, like binsh, like scripts. So like when you're working interactively, maybe like Bash or something. But when I'm writing scripts, I tend to make them just board shell, so it's portable, just in case. Because I got bit by the Bash fairy a couple times when I was switching between major versions of Bash, and like all of the syntax changed. It was like, well, that wasn't expected.
I feel like on many Unix systems, on many Linux systems like the binsh, it's actually powered by Bash.
Yeah, a lot of them more either Bash or it'll be like Dash or something like that. Yeah, kind of BusyBox style, where it's like overloading the same binary for different functionality depending on how you call it. You know, normally when you're dealing with programs or whatever, you kind of ignore $0, you know, the first argument to your function, because that's just the name of the code you're in. In shell scripts, sometimes you'll use that for documentation purposes, because you're like, well, I don't know where they stored it, so I don't want to confuse the users, so I'll just put $0 in my error messages, or in C, you would use, you know, argv0 or whatever, the equivalent in many other languages.
Speaking of BusyBox, today Era, they actually had an outage, and you could, are you guys familiar with Era?
Era, oh, like the Wi-Fi?
Yeah, the Wi-Fi.
Yeah.
They had an outage today, and it's kind of interesting because they recently introduced like the thing where you can block like ads and like domains and things like that. And I had that blocked, and like it wasn't blocking today. And I'm like, what is going on? Like, why do all these ads keep showing up even though I blocked them? And it turns out they had an outage. It's supposed to be locally blocked, so it's kind of like pretty strange that like that local block thing is still effective when they have an outage elsewhere.
So was there any big Go news this week with the GopherCon and everything? I haven't heard anything yet, but it's still ongoing.
Normally they release the videos that like pretty quickly, usually like a week or something.
Yeah, I'm sure they'll get a pretty good turnaround. Okay. still waiting on pizzas. They're supposed to be here soon, any second now. But
So like 6:30 something?
yeah, last time I told them to get here at 6:15, and they delivered all the pizzas at 5:45. And this time I told them to deliver at 6:30. Trying now or
Just in time.
I know, right? Right.
Yeah, I think I have a moment during the day.
I'm a little surprised I haven't heard from him in a bit.
So you're expecting, what we expect?
I'm going to spend more time explaining that. Unfortunately. We'll get to the why here in a minute.
Alright, back to the domain. Okay, cool.
Nor the flies.
Yeah, I noticed that. Okay, condo then, huh?
Like watching agents. Another thing I was thinking about was like, obviously laying down an infrastructure and then like having a specific flow with the tier on the first side, and then when the new client signs on, then instead of having virtual assistants on retainer assets, like whenever someone pays the tier or we get some kind of income in when somebody signs a client, then we use tax funds to get virtual assistants to sign on. That's
Right.
essentially what.
Sure, but I think that, I was talking to, I think you need to.
Right.
Because he's very young, and he has a lot of energy.
Which one?
The one I was talking to.
Sir?
I gotta say, it's been long enough since I've had to go on a daily basis. I did not realize that now Go
I was talking with him.
always puts
Okay, but here's the thing.
version numbers inside of requirements, which just ticks me off just a little bit. Like that's what Go.sum is supposed to be for, so why are they doing that? I get why they're doing it, but I'm displeased.
And bring the other talk.
What was the marketplace for that?
Yeah.
I'm one of those folks that if you have a reason to have a specific version, that's when you put the version in your requirements. You leave it alone, get the main, master, whatever, just the default. Always, unless you tell it you don't want that. That way you've always got software updates. You're not gonna be surprised when things are way out of late. Expect is just a string. Very close.
Okay, I'll be right back.
Yeah, you're good.
Yeah, then on the first one, you
Yeah, I thought, our other organizers, 2 of them were at GopherCon and the other one is sick today. We're running on, oh, looks like that may be them. Hello? Hey. Okay.
I can go try to find them.
Yeah, they're standing right outside the gift shop, if that's all right. Okay, yeah, we're sending someone down. Yeah. He might need help, so, yeah. Okay, yeah, we're sending someone down right now. All right, thank you. Okay.
One time I came here for the next one. Meetup didn't say where they were in town, factory. There's nobody here at that desk. There was an event on the first floor, but there was no townhouse talking about.
Yeah. Huh. It is, understandable when you first get started that things going again, that things need to get worked out. So like that's last month we were like, hey, we got the cables, right? And everyone's like, yeah, we got cables. Nobody had cables. So we had to go get cables delivered at the last minute. And this month we're like, okay, we've got my talk and then like maybe backup talks and stuff. And like, nope, no backup talks, just my talk. Damn, okay. Alright. So, but I think after a couple months, we'll be back
I'm just
to.
saying, Capital Factory doesn't really have any, if you're after
Yeah.
hours,
Yeah.
you're kind of on your own.
Yeah. Unfortunately. Yeah.
Yeah, because this group had kind of fallen apart. I had, started, some guys offered me 4 work and 2 month guile course, guile scheme.
Oh yeah.
I'm kind of doing that, and then I'll probably get back to looking to go.
Yeah, fair enough. Yeah. If I can get just the Google and Netflix ones working, I can just show what the other one would look like. I think that'll be okay. I mostly had it, but there was a few things left. All right, cool. So we got 2 of each. 2 of the pepperoni, 2 of the margarita, and 2 of the cheese. I will go get shoes and stuff. I'll be right back.
This one's pepperoni. sponsored yourself again, or?
Well, yeah, I just sponsored myself. So.
Yeah.
Yeah, thank you.
Thank you.
The Waterloo ones kind of suck. Part of that. Their boxes suck. Yeah, I am a little worried that there might be some people stuck, but you know, I guess if y'all saw anybody, you would have brought them up.
Well, it was pretty clear that it was like 16.4. It said like Antone's on 16th, right?
Yeah, yeah.
But on
It's
the other
just
hand-
last month we did it on the 1st, so.
Alright. But you could maybe print like a label or whatever and put it there, your concern.
Yeah.
And the 1614 is fixed. So you need to-
Okay, yeah. Must connection dot. Hey,
Hey, I'm
we
right
got
back.
pizza.
Okay.
Alright, yeah, we got pizzas and we got beers and we got the drinks and stuff back there if you want, Waterloos and Ramblers and stuff. Alright, make sure this is working. I think it will work. Run. Regex. Oh, really?
You wanna watch it?
Alright, I'm guessing this would work for the YouTube. So we are streaming, I believe by now, we are streaming on the YouTubes. Welcome to the Go Meetup. We're getting started a little bit late. We got the pizzas here a few minutes late. Definitely thanks to Capital Factory for sponsoring and letting us have a free space and streaming a video. It's pretty cool of them. We have got plenty of pizza. We got you know, drinks and everything. So definitely dig in.
Thank you.
Yeah, absolutely. You're welcome. We are definitely looking for more speakers. You know, we're just getting started again. This is our second month back this year. So if you've got ideas, if you've never presented before but are curious about it, we've got people.
I don't think that microphone works. I think like the microphone is like somewhere else.
Oh. Somewhere else in the room or whatever?
Yeah.
Oh, okay, could be the one over there. Okay, yeah. Yeah, so we've got plenty of people who would be happy to help you get your talk together and everything like that if you've never spoken at an event like this before. So definitely reach out. If you even if you've got an idea and you're not sure how to, you know, where to take it or whatever, reach out. We can help you. You know, you're not signing up for next month. You're just, we'll get you on the calendar so we can get you several months out and everything ready to go. Yeah, so there was one last thing I was looking at on my end. Oh, I see. So, we'll go ahead and refresh here. Refresh. Alright, I will go ahead and get started. So, I was originally going to give this talk back in April of 2020 at the Go Meetup here in this room. Of course, we did not have a Go Meetup in April of 2020. It was about a year or so later before we started meeting once again up at Foundry 5 on the north side. And it was great to get back going like that. And so we're definitely appreciative that they were able to get the thing going again at that time. But a thing, when I said that I was going to go expect, initially this was based off of the fact that I had done some quick Google searching around. I've been trying to learn expect for my own purposes, just the original tickle expect, and was a little bit surprised at what I found. So let's take the high level and kind of go through this. So this whole story started at NIST, the U.S. National Institute of Standards and Time. And so normally I think when you think of NIST, you think of, well, this is the group of people that handle like, how far of a distance is an inch, or how much, weight is a pound, or what's, the time synchronization for the government and things like that, getting everything ready for like the GPS satellites and stuff for timing, because it's very important for GPS. And so that's usually what you think about with NIST, but one of their things that they do at NIST is set the standards for what is an acceptable piece of software when they are contracting software out for the U.S. government. So when the U.S. government, certainly at the time, I think now there may be a little more flexibility, but in the late 80s, early 90s, when computers were still a pretty new thing to a lot of people, if your organization was outsourcing some major piece of software to a third-party software provider, you needed to have some way of knowing whether or not what you got back was what you agreed to pay for in the first place. Like, it was a bit of a hurdle when you're talking about people who were just not that comfortable with computers at all in the first place. And so it kind of fell on NIST to do this. But one of this problem, if any of you've worked in large projects before, the definition of done is a pretty big issue when you're dealing with the kinds of projects that involve like a dozen people or 2 dozen people. So when you're talking about software, which may have involved hundreds of people, sometimes thousands of people, the definition of done becomes quite a big question. Especially, again, we're talking about a time when computers themselves were somewhat alien to most of the people involved. So this person who worked at NIST at the time, Don Levis, he created a tool called Expect, and the whole point of it was black box testing. So it's like, I don't really care what programming language you wrote this in. I don't care what kind of computer you have it for. Like, we bid out to say that this software problem solved on the network or solved in some circumstance, and presumably the price that we're paying includes the cost of the computer. So I don't care what computer you use, as long as it does this thing. But we have to be really clear about what this thing even is. And so that's where black box testing comes in. Where you're like, I type these letters on a keyboard, what comes out looks like this. Now if it's literally a keyboard, maybe Expect won't be as helpful. But the idea is if it's something that you can pretend looks like a keyboard, then that's where it really comes in. It's really handy, And so Expect was a killer app in that particular domain of like, you have something that's over the network, you need it to work in a very particular way, or sometimes it's even just the system. It's not a question of testing it; it's a question of automating something. And so, kind of one of the first examples inside of the official Expect book is the password command. So think back in the late 80s, you are a Unix admin, and you've got all these new users who got onto the computer. They don't have access yet. You need to set passwords for them. How do you do this? Well, there's not like a thing, maybe there isn't depending on which Unix provider you're talking about. There's not generally a thing that you can pass on the command line that allows you to set a password. Not in the original Unix spec. The way you would do that is it prescribes what does the interaction look like with the user. And that's great once they already have a password, but it's a chicken and the egg problem for large organizations. How do you set up the password for these people one at a time? Sysadmin's job is way too important to have the people report to the sysadmin one person at a time while they sit there and walk them through typing their password. Like, no. What they're gonna do is they're gonna issue it, they're gonna print it out on pieces of paper, they're gonna give it to them when they start the first day, and then the first time they go log in, they have to go change it. These kinds of things are all automated now, but at the time, how would you do that? And so expect one of the things that it can do because of its usefulness as a black box testing system. That means that it's really kind of operating from the outside. So it doesn't care if it's reading from standard in or if it looks like it's typing on a console. Expect has the tooling to make it look like it's typing on a console. That's the whole point. Like they wanted to make sure that they can automate the testing for all of these different systems to see that it behaves exactly the way that we expect it to when someone is at a console and they're typing letters or something like that. That flexibility in circumstances like that make it really useful for doing things which are purely networked, for example. So if you had something, some completely new protocol, and you just wanted to quickly try it out or something like that, you could open up Netcat and manually do some things. If you tried to use shell, like piping and with echo and stuff, there's a lot of errors that you'll run into. Things won't work quite right. It gets more complicated now when you're talking about, okay, well maybe you got it to work once, but now you want it to be portable. You want the same test, the same automation to work on this, Unix system over here, but then there's a different vendor who has a different Unix. The password command works the same way, for example, but exactly what characters are going over the line. This one's fsdig or whatever. It's like weird crap that you shouldn't have to care about as a sysadmin. You can abstract those things away in the same way that we do inside of programming. Like you don't, when you're writing Go code, you don't have to care if it's big endian or little endian. Where you're like, what's the byte order? It doesn't matter. You're just adding two numbers together. That's fine. Those things are abstracted away from you. Expect allows you to do that for black box testing. And so if you get a chance, there's the book. When he was making Expect, he was realizing that in a lot of ways this would be a lot more useful as a domain-specific language. And I don't know, any of y'all are familiar with the idea of domain-specific languages? So basically the idea is that it's a specialized programming language which is more optimized for a particular kind of problem. They were very controversial in the early days because people tended to go kind of off in the weeds with them. They were trying to reinvent new types of programming languages and it didn't work very well. These days, because we have better tooling, it's not even that odd. You probably have used libraries that would have considered themselves to be domain specific languages at this point. If you ever deal with Jenkins, there's like a subset of Groovy, which is the Groovy DSL, and that's basically what's happening here. Tickle was kind of this brand new idea of a programming language that's specifically designed to be used for this kind of stuff. So it's basically this programming language that you wouldn't write code in. It's not going to be competitor to Go or to C or anything like that. To give you an idea, I'm kind of dropping details for later in the talk. The closest one you would think of today would be Lua. You're you're not gonna write a big complicated program in Lua. Maybe it's not impossible, but that's not what you're doing with Lua. With Lua, you're configuring something else, or it's embedded in some other circumstance, or you've got some really complicated code on the back end, and then Lua makes it really quick to just piece the bits together. And that Tickle kind of invented this idea of a language that is used for specific kinds of purposes like that. They use it at NASA. They do it for controlling like the ISS. They've got some stuff that they do with Tickle. There's a lot of embedded circumstances, you know, where you're testing things with expect usually, but possibly with just maintaining things in a way where it doesn't have to be programmers running. It could be like the electrical engineers could write the code. Electrical engineers don't have to know algorithms to do the code, right? Like they don't have to know like, oh, did I implement bubble sort instead of merge sort or something? Like they don't have to think about that. They're just like sort whatever, and then the programmers can come back later and fix up whatever they need to. So Tickle kind of came into existence around the same time as expect, and so expect was created for Tickle. So here's an example of some Tickle expect code. So we're spawning a shell. We're creating a process in the background that is just bin sh, real simple.
Can you zoom it in?
I think so. Yeah.
Commit plus true.
Yeah.
Thank you. There we go.
Yep. So we create a shell. We expect to see $space somewhere. We'll get to, there may be more than just that, but we'll also see a $space. Once we see the $space, so that's what expect is saying. Now, I'm expecting to see $space come out of this program. Once I do, I'm going to send echo, hello, expect, and a new line. I'm sending that to the same program that I just saw the $space come from. After that, after I've sent that, I expect to get back the literal text hello, expect. And after that, I then expect to see another $space, another prompt. And at that point, I'm going to type the word exit, and then I expect that standard out has closed after I type, at some point after I typed exit. Now there may be other text, maybe it says logged out, maybe up here for before the $space, we see some like what we would call Etsy issue stuff, so it would be like, you know, this is, you're logging into this computer and you're, you know, yeah, you're gonna get in trouble if you break the rules or whatever every time you open the shell. Like you could do that. But we ignore all of that stuff. All we're doing is we're waiting until we see this $space. Once we see the $space, then we proceed with the next step. And here is the output that you would see. So expect will actually write the fact that it is opening bin sh, so spawn bin sh. And then this is literally what it ran. One of the things that's nice about expect, if I change this from bin sh to bin bash, which wasn't originally planning to do demo gods, but we will see if they're smiling on us today. Sometimes they smile on us, sometimes they do not. We'll give it a shot. Okay? Oh, come on. What is it? Oh, damn. How do I increase the font on just this here? Control plus plus? No.
Probably those.
Is there a zoom option on the upper right on the directory?
Three lines.
Do this search first.
Okay.
Preferences.
What are you writing, Liz?
Of course.
What?
Well, most of my newer versions of Ubuntu will definitely have a thing to do with that. But I was seeing that when I'm typing control, it's like, oh, control mode. I'm like, no, that's not what I meant. No. So,
I had to ask, why is it pro?
oh, sometimes when you get a nickname, it just sticks.
So that means when you screw up, you really screw up.
No, it was
Lost that screen.
oh, I lost it. Oh, that's annoying. All right. Well, we'll hopefully it'll come back. Expect command. Get in there. Okay. So let's go and mess with the hello.exe. Okay. So we can see that's the one we were running a minute ago. We're gonna go run it. Okay. Did what we were saying. Okay, now it's back there. So let's go and change this to bash. Let's see. Probably user bash, I would guess.
And what's the difference between expect and tickle?
Expect is so in a sense, expect is an extension on top of tickle. But tickle can be embedded in other languages like Lua can be. Like you can embed tickle as a configuration language that gets run inside of your C program, or an expect I think is actually written in C, but it's wired in with tickle. So there's a copy of tickle that comes with expect. So when you run the expect command on the command line, it actually has a copy of tickle embedded into the expect program. So it is the expect, in a sense, it's like backwards from how we would often think of libraries, is that you have the programming language and then you add libraries to that. Tickle and Lua are languages that are so small that they are intended that you can do it the other way around. So expect, we would think of as like a library, but in fact, in this case, it includes a copy of tickle in it. Okay, so when I run this now, you can see, whoa, like it's writing out my PS1, my whole line here every time. It's not just the $ like up here. It's actually the whole line. And so so that's different, you know. But that's the trick is expect doesn't care. All expect is looking for, as we said, it's looking for, did I see a $ space? And inside of this one, we also see a $ space. There may be like colors and stuff in here, doesn't care about any of that. It just sees $ space. Once I see that, I'm going to write echo hello expect, and I'm going to press enter. And I expect to see this hello expect thing come out of it. And then I expect to see a $ space, at which point I'm going to type the word exit, and then I expect to see an end of line. And we can see that it, that expect command, it's a little bit confusing since we're back at the same PS1 line, but that was, these actual two commands were actually run inside of the expect there.
How long you will wait for there is some time out?
We will get to that. Yes, that is the right question. So, well, what if you get unexpected output? A little bit of a fun twist here. Instead of writing hello world, we write something different. But we are still expecting to find hello expect. So I'm also introducing a little bit more of the tickle syntax here. In that expect here inside of there, what's really happening is every one of those things you say that you're expecting is actually then triggering my next response. So it's a little weird if it gets to the end of the line and you didn't have like a new chunk that it's supposed to run, then it's going to say like, oh, okay, we succeeded, continue to the next line. saying, okay, we expect to either see hello expect, and then we're gonna run this expect continue thing. Or it's gonna time out, in case we're gonna write timed out, and then exit, and that'll give us a non-zero exit. But if it all succeeded and we didn't exit out of here, we're gonna do our normal safe, give us back a status code 0 exit at the bottom. And so you see down here, we did not see hello expect, and so it said timed out, and then you would be able to see that we actually got a non-zero exit out of that entire expect script. Run a little bit. So view unexpected.exp. Okay, again, like we're spawning binsh, we are echoing a thing. We're saying that we expect to see this hello expect, but if we didn't, we're going to say timed out instead. And so when we actually go run it, it'll take a few seconds. So you see it's just sitting here waiting. It's waiting for it to say hello expect. It's still waiting. And then timed out. And if we check what was the error code, that was an error one. So that one was unsuccessful. And again, it wouldn't matter, just as before, not them, not you, yes. Let's say that we change that to bin dash. See, just bin dash will work. Okay, and we're in the same situation. Now it's just like sitting here waiting. It's expecting to see hello world. Didn't see it. Timed out. And again, $$ question mark. We got a non-zero exit out of the expect program. So you can have fun with this. Another interesting one. This one clipped out, but this case, we're going to go look at port 80 on Golang.org, because looking at 443 gets a lot more complicated at that point. But we could do that with SOCAT or something like that, and that would work just fine. We're going to go pretend like we're a really old web browser. We're going to say that we're running HTTP 1.0, and that we are looking for the front page of Golang.org. And in our case, we're going to say, we're a little more complicated here, this example I'm showing off, where we got this timeout thing. So if we sent the thing, it didn't connect, and it died. So like we changed the port number, then we would get this dead instead of everything we wanted to see. If we, or even if we put 443, it would die, because like it's not expecting to see this get / thing on port 443 in an unencrypted way. Assuming that we do get a response back and it says something HTTP / something. It's like, oh, okay, inside of that, we're wanting to see, is it like a 200 okay? And then we're going to write okay in screen. Or if it's a 301 move permanently, or a 302 found, or a 308 permanent redirect. And if it's anything else, we're just going to write the word what and then exit one. And it kind of got, the output got clipped off here, but I can go run it real quick since we're so far batting 1,000 with the demo guys. There you go, I found. So we spawned netcat to golang.org on port 80. We're just looking for / HTTP 1.0, like old-fashioned HTTP request. And we got a 302 found. And so we said, oh, we got found. And that was the type that we got back. And again, we can see that we got 0 back. And it would be easy for us to like go and fiddle with this, see that it's doing what we would anticipate it to do. Let's say, something that's nonsensical, like it's a 312 found. Okay. It's not going to work out. And so it's hanging there. It's like, wait, what? this, okay, yeah, we got a what. So it wasn't dead, it didn't, we had those two different ways that it could exit. It could have exited with a regular timeout on the outside, or we didn't even get the HTTP slash back. So that would have said dead. We got a what instead. Okay. So now let's go try a different port, for example. Okay, let's go fix this one. Let's see. I'm assuming they're not going to respond to unencrypted traffic on 443, and we're about to find out. Okay, let's see. What do they do on 443? No, they got something else. Okay, interesting. What if we did?
So it's probably seen that when you send it, it sees that it was echoed back. That's why it still does what.
Yeah. Well, it probably died immediately, so it didn't time out. That could have been what it was. So let's try this. Oh, it shouldn't have echoed back though, because not on 443. I wouldn't expect it to echo back.
No, but what you send echoes back.
It echoes back
When you
to
send
us.
it. Yeah.
But expect knows the difference there.
Oh really?
Yeah. You could set it up to do that.
Well, but it like the what thing is inside the HTTP slash, so it must have seen that it was sending it.
Yeah, I don't know. That is weird. That's a good point.
I've used expect previously, and like it was always working very strangely.
Yeah, I think you're right, because we're getting that.
Right.
That's fine. Maybe if we did telnet or something instead of netcat, maybe that's our problem. So yeah, let me go put it back. So Golang.org. So that is.
You should probably try matching it like that. It's at the beginning of the line, like the HTTP starts at the beginning of the line. That way, you would not match it sending
that's
it.
Good.
Yeah,
that's a good one. We'll try that. We'll do that. We do have to do regex though for it. So here a little more syntax for particular expect. If you start with -re, it knows that it's not a static string. It's trying to go in and interpret this to mean something at that point. So let's try that.
it doesn't work anymore.
No, because that's looking not at the beginning of a line. That's looking at the beginning of that line. Okay, so we need not that. Okay.
Probably dot star and then.
/n maybe? Maybe that would do it. Because it would be CRLF, so LF right before HTTP.
/b maybe.
Maybe. Yeah.
Word boundary. Oh no, the B wouldn't work because it has to be. Yeah, this one works.
That works. And so then if we tried that 127.01 W27001. There we go. Yeah, so it got an instant close, which it wasn't expecting. So it died in a different way than it was expecting to die for that one. So it didn't go dead, like the whole thing dropped. So if we try the 443 one. Golang.org, because that is a network you would actually try to connect on, but it would not actually respond in that way. No, whatever.
It probably dies like
Demo
as soon
guy.
as it probably dies as soon as you don't send the crypto thing. So like if you send something out of encrypted, then it probably closes the connection right away. So that's why it has the time end.
Yeah, could be. If we'd send it to an email server or something that it's expecting text, then it'd be like, what the hell is this? Like, so, anyways, yeah. So the syntax is a little weird, like with the -RE thing, like in the middle, and you got all these different, and then like default, and like, you know, what is the scope of this thing? Like, is this thing you know, see, like we're kind of mixing. If we put a string after expect, then that's the thing that we're expecting to see. But if we put a block after the expect, then it kind of becomes like a subfunction. And so that's the nature of Tickle. The syntax of Tickle is a little weird. We didn't even get into the weird syntax of Tickle, where things like all these quotes that's like a special. It's not always that quotes do what you expect them to do in Tickle. So sometimes you have to start using square brackets, and square brackets mean something different than quotes. They get interpreted differently. Tickle is nice for its historical context. There are still places where it's used, especially with expect. But there's a reason why it's not the most popular domain-specific language anymore. And so the thing is, for like really simple scripts, maybe it's still good, but okay, well then why are we talking about this at the Go group? Why are we talking about any of this at the Go program? And well, it's the Go Meetup, that's, you know, we're looking for Go expect. But Tickle expect is a really good way to test really simple network programs. When you're like, I sent this, I expected to get this back. I sent this, I expect to get this back. Well, a lot of those, if you're talking about, I'm going to throw something together real quick like that today, you probably were going to do that in Go. And so if you're already writing probably the thing that you would have traditionally tested with expect today, you're doing it in Go, then why not also do your testing for those systems in Go? That's part of it. Also, just the kind of the way that you think about networking in this, like we're abstracting away the right components of networking, kind of matches well with the way that you approach working with networking code from the server side in Go as well. So it seems like philosophically it's a good match. Yeah.
Yeah, I think you mentioned email, and I think email would actually be like the better example for like why you would use expect. Because HTTP, you basically just always only make like a single request, right? And you get like a single response. So you can already automate the HTTP thing with just like a regular shell script. But you cannot do, you cannot automate like with a regular shell script, like do the SMTP transaction. Because for SMTP transaction, you send like multiple separate commands, and then you expect a specific response for each command. So that's kind of like where the expect comes in.
Yeah, yeah. Well, and that's another one of these, you know, other examples that they have are things like, you know, FTP is one that always comes up, where you don't know, is this FTP server going to allow you to log in as an anonymous user or not? You know, does that come up very often today? Maybe not. But again, that kind of pattern, where you're like, I know I'm going to connect to this thing. I don't know if it's running on my laptop. I don't know if it's running inside of an IDE on my laptop. I don't know if it's running on my local network over the internet. Maybe I have to talk to it through an SSH tunnel over the internet. Maybe it's running on a different architecture. Maybe I have to authenticate first. Maybe I don't in this circumstance. Or in this, I want to do the same test 3 times in a row on the same server, but I want to see that the only thing I'm changing is how I'm authenticating. Like all of these things are things you might want to do. And how are you going to do them in a particular programming language? A lot of times you have to reinvent the wheel. A pattern system like expect is going to be really conducive to that. And so much so it turns out several people thought the same thing. So we have got several implementations of expect in Go. Google made one, Netflix made one, Thomas Bruni apparently made one. There are more, but these were the ones that had the highest, you know, in Google anyways.
Who's Thomas Bruni?
What?
Is he famous in any way?
Dude that made G-Expect. But it's one of the ones that shows up quickly. A lot of people make references to it and everything. None of these have been updated in years. In fact, the Google one is officially deprecated. So it's like, shit. Like, well then, like, where did this go? Well, maybe not all is lost. We'll get to that in a minute. There are forks. We live in the open source world. Forks exist. So here is what, again, Tickle expects version of the hello world thing. So we're creating a shell, we're spawning one, doing the normal, looking for $ space, sending hello expect, all that kind of stuff. Here is the Google one. Okay, so it's in Go. We're setting a timeout. Our expect one that we had previously, this hello expect, we didn't have a timeout. This one we're setting one. We'll show you why in a second. So we've got a spawn here. And I just got must error, so instead of filling the screen with the normal if error null stuff. And then we're deferring our connection closing. We'll get to down here at the bottom. We're getting a regular expression. So Google's expect is only using regular expressions. It doesn't do anything else. And so if you want to use Google's version of expect, you have to give it regular expression. So in this case, the prompt is just the regular expression of a $ space. It matches if you give me a $ space. And we're giving it a timeout. All of the Google expect commands include a timeout by default. You can give it more stuff, but you have to give it a regular expression and a timeout. And then once, assuming that it didn't have any problems, then we send hello expect, and then we are just in time compiling this hello expect like we had before. Again, like it has to be a regular expression. That's just the way that Google's works. And then we get down here, you know, connection expecting the prompt again. So just like we did before. So you see, like we're doing prompt echo hello expect. We expect to see hello expect. We see the prompt again, and we exit. Same thing. Prompt. We are echoing hello expect. We're expecting to see hello expect. Prompt. And then we're writing exit. But the run thing is not working on my particular version of. I've got a different version of Go running in Snap versus present. So I will just go run it for you real quick. So go run hello Google.go. Whoops. Timeout error. No, this is not bad.
This is expected.
Yeah, well, it's expected. Actually, it was not expected, but we anticipated it. So it is. Yeah. So we got a timeout error, and so it's like, what? Why did we get a timeout error? If we go back over here, it's because this prompt, and well, this hello expect here is greedy. And so if we go, I made a debugging one that we can go and see exactly. So we go look at the hello Google. So this regular expression, this hello expect here, is greedy. Okay, what do I mean by that? Google debug, I go. It's basically the same thing, but I did the stereotypical extra log printfs everywhere. I'm actually, instead of ignoring all the response data from all the expect and send commands, I'm actually recording them and writing them out to the screen. And so it's the same thing, I just put these log prints everywhere. So we're not doing anything different, except instead of musts, we're letting it run all the way to completion. Okay. So what is this going to do? Aha! So when we got the prompt, okay, so that was all cool. We saw the $ space. Inside of here, we got an array that included $ space. Good to go. Got no errors back. Then we sent the command. We didn't get an error when we sent the command. We saw the response, hello, expect. That was exactly what we got in the string back. Good to go. Prompt scene. We didn't see anything. But if you look back on that line before where we said hello, expect, that was the one that matched. What's before that? You see a $ space there, right? That is the first argument. That was the first thing we're getting back. So we go doc.github.com/Google/go expect, and we are looking at, what is this? This is going to be expect. Yep, there it is. So we're getting back a string, an array of strings, and an error. And it's not very helpful telling you what these things are, but I can tell you that this kind of matches the behavior that you're getting in a certain sense in all the Tickle stuff. Is that Tickle's creating all of these variables in the background for you. That's how all of this stuff is working automatically. When you say expect, spawn, when you create a spawn, it created all these variables with default names. And so when you run expect, it knows to go and use all the default variables to do stuff. When you run send, it knows to use all the default variables to do stuff. So there's all of this stuff that's getting set when you run an expect command inside the Tickle. You can go and inspect these things directly if you want to. And in the case of Go, it's not going to go and update a bunch of crap like default variable names in the background. That's not how modern programming languages work. They just return all of it. And so in this case, string is the part of the buffer that we just ate just now. This array of strings are the chunks that we saw that matched the thing we were expecting to see. And then we are getting an error back. And so in this case, by the time we run that expect, hello expect, it ate the next line already. So it already saw that $ space. And so it's like, okay, we're done with that. And so then our next expect line comes in, and it's like, what's going on? And so it's a little bit disingenuous because we could have actually done the same thing inside of Tickle's version of expect. The difference is, and this is something that won't be a surprise to Go programmers, Go doesn't care where the new lines are. It will just keep reading as long as you've got stuff on the buffer ready to read. That's the way readers work. They're not going to stop just because you get a new line, unless you call a reader in a way that stops when it gets to a new line. Tickle, by default, is running one line at a time, unless you change the mode to make it not be one line at a time. And so, if we go back, looking back here at this HTTP example, you see I've got this expect with the 200 OKs and stuff nested inside of this HTTP / function. If instead I move this out afterwards, you would think, oh, it's the same thing, doesn't matter, this is just like a code flow thing. No. The expect that's running inside of this HTTP one is continuing with that same string in the same way that we just ate that $ space for the Google one that we were looking at. In this case, it ate the entire HTTP / 1.1 space 200 OK, whatever it is. That's an entire line. So Tickle expect by default, it's going to eat the whole line, and then it's going to bring you to the next line. But when you nest these expects like this, then you can get around that. I suspect Google's is going to do something similar, because you see, we're using this approach, but there's actually more stuff going on. Let's expect. You know, like expect batches and expect switch cases and options. And, there's a bunch of other stuff you could do. There's probably similar tricks, but you see that the equivalent isn't even 1-to-1 here. Like, it's not exactly the same between Go's expect and the tickle expect. And maybe it shouldn't be. Like, Go's a much more flexible language. It's a better language for doing this kind of thing in general, probably. But the unfortunate side is the documentation for tickle expect isn't always great by modern standards. I mean, that book is very helpful, but it's not been updated in, I think, decades at this point. And so some of it doesn't really resonate when you see them talk about like the different types of FTP servers you can connect to. It's like, well, how many of you connected to an FTP server today by hand over Netcat? Like, well, probably none of you did. So like this like, isn't it great that it makes that faster is probably not something that's going to resonate with anybody. And the examples they give of like, you know, wouldn't it be nice if under this circumstance when you saw that, like it works a little bit differently? It's like, you're not even going to have the context of what they're talking about.
Well, people still use the mail servers though, like you can still.
Oh, mail servers for sure, yeah. And there are people still using FTP servers. I know where I work, it comes up often, but I don't do it. but there are people who do. But yeah, so you know, in a sense, you still have to learn the tool. There's still a learning curve. The documentation isn't wonderful yet, and I think that part of the thing with it being a deprecated repo. I suspect that was part of why the repo was deprecated, was because Google probably didn't feel like all the documentation, all the support and everything was quite up to where they would want it to be if it was going to be a supported thing. Netflix's version is kind of interesting. It almost feels more like a Go approach in some ways. It looks very similar. You see, I mean, almost all the commands are the same here. It's breaking at the moment because the send command is actually returning two things. It's returning an integer, I think, for the number of bytes that it sent and an error instead of just an error. So my musts are breaking here, but everything else is working. The biggest difference here, if we go back and forth here, you see the Google expect one is actually doing the spawn for us. That's the normal way that like Tickle's expect does the spawn. Netflix does not do the spawn. They're like, this is a design choice. We won't do the spawn. And so it's like, well, isn't that like part of the point of using expect is that you can swap out like what you're testing against? Like, doesn't this break the portability? And they have a very good point. They're like, no, Go is better at fixing this than Tickle is. Like, you just have to tie in the standard in, standard out, standard error. That isn't the thing that would be a problem for a Go programmer. Like, you're like, oh, you just have to wire these things up to whatever. I don't care. I don't care what this thing is. Like, you could have a command, you know, OS exec command, or it could be an SSH connection, or it could be something over like a serial line, or whatever. Whatever it is you want to do, your Go code can swap this out at runtime. Whatever mechanism you want, as long as you connect up the TTYs here to it, it's going to look like a TTY. And so expect is going to do exactly what you want it to do. And so this is the Netflix approach, is that the actual commands are largely similar. They do have a little more flexibility. They're not requiring you to do regular expressions. Another thing I kind of glossed over a second ago, how do you collect an EOF with the Google one? I bet there's a way to do it. It wasn't documented. Like the official Tickle expect one has like a specific thing for expecting an EOF, but the Google one didn't really make it clear how you would test that. And it's a really common thing that you would want when you're doing black box testing. Like it's very important being able to say, and now we want an EOF. And so it wasn't clear how to do that in the Google one. Crystal clear in the Netflix one. And so there's some advantages. We've got static strings here instead of regular expressions. If you want that, you do expect.string. You could do an expect.regular expression. You could do your timeouts. That's how that works inside of the Netflix one. Instead of like with the Google where every time you have to specify what kind of timeout, or you can put a -1 if you want it to be default, or 0 if you don't want it to ever timeout. That's more of an automation than a testing thing at that point. The Netflix one, your timeout stuff would be inside of, it's like one of the arguments you pass here. And so you're constructing your combined expect object that you're sending. This one is not listed as being deprecated, they just haven't updated it in 8 years. So, okay. There's also this other one that we mentioned earlier, this Thomas Rooney one. That one actually looks a little bit more like the Tickle one. Like it seems a lot closer. It's got EOFs and stuff. It's got timeouts as optional every time, but it also includes spawn. A lot of the verbiage is the same. I think it was implying that it's line oriented and stuff by default. So it's closer to Tickle's version of expect. But it's like, well, like I said, none of these have been updated in forever. There are no active forks of the Thomas Rooney one either. But for this Netflix one, you see, we actually have several forks that have had recent commits. And so while Netflix has not themselves updated their version of expect in like 8 years, but there's apparently still people out there with their own copies of it who are working on it all the time. There's like 150 forks of the Netflix one, and people are making new features, new bug fixes and stuff all the time in theirs. And so while maybe Netflix themselves aren't actively doing it, it seems like there's interest in this kind of thing. Maybe the more interesting one is while Google has officially deprecated theirs, and so they're not accepting new bug fixes, not anything. And yet, the top fork they've got here, Tailscale, who seems from all of the documentation and stuff like they're actually using that internally. And they've got recent commits and stuff in it, so in all likelihood, that's probably like a thing they're really using day to day there. And so while the Google version of it isn't still being updated, their fork looks like it's probably fine. And I personally, if they're just like, now it's the Tailscale version of GoExpect, would not have a problem with that. Like, yeah, I would totally use a tool that they made. And so, before we get any farther, I just want to point out, there are a couple of these tools though in Go. If you go digging a little bit more into Go, expect implementations in Go. You've got this golang.org xtools GoExpect. This was the thing I got excited about because I saw this became officially supported somewhat recently. Like, oh great, a version of expect officially. Like back in February, March of 2020 when I was trying to make this talk the first time, I noticed that like none of these things had been updated in a couple of years by that point. And so I was excited to see this thing is now officially supported. That's a totally different thing. I mean, like maybe there's some tangential relationship here, but the Go tools and xtools GoExpect, that is a tool which helps you to unit test other tools which generate unit tests for Go. That's
tester.
what?
Like a tester.
Yeah, basically. It's a Yodog tester for a unit test auto generation. Yeah. So it is a tool that helps you parse annotations that you put around test code where you have written a different tool that creates test cases for the test code. This helps you test that other tool. So kind of obscure, like weird, don't know why that's officially supported. I mean, good for them, but like I'm really annoyed that they picked that name. Like a 2-syllable name for an extremely obscure problem that probably like 3 people in the world have ever actually run into, but okay. really weird, but all right, cool. There's this other one, Carl Sagan expect. It seems like it's actively maintained and everything. It looks nice, but that was, we were talking a little bit earlier in Ruby. There's this idea that you see a lot, where you're trying to make a piece of code read aloud the way that you would say something like what it's doing in English. So you're mixing together like verbs and nouns and things like that. It's just a style of code, and it can be helpful for quickly diagnosing what's wrong or things like that. So it's a decent pattern, but it has nothing to do with expect. It turns out that like that library in Ruby that introduced specifically doing that for expect for like unit tests and stuff was inspired by expect. And so I think it's my understanding is that Ruby library actually implements parts of expect in a very Ruby way, which is great. You know, like that's great that they adopted the ideas and then like made the Ruby version of those ideas. From what I can tell, this is an attempt to take like the verb noun ideas for writing unit tests in Ruby and trying to do that in Go. Not a bad idea necessarily, but it's a little annoying that they're using the word expect to do that when that tool definitely is not adding. It's only like syntactic sugar. It's not doing anything different. It's just syntactic. And then HTTP expect, you know, I was thinking, well, oh, okay, so it's kind of like expect, but more narrowly focused just for doing like HTTP stuff. Like, you know, we were doing, you know, HTTP stuff a few minutes ago. There. We were doing HTTP stuff there, so maybe it's just like automating more of this kind of stuff. No. That HTTP expect is somewhere kind of like the Carl Sagan thing a little bit, where it's just making it a little bit easier. It's embedding more test patterns that would be useful in a reader when you're specifically looking for HTTP. Another very valuable thing to exist, but maybe a little annoying to call it expect. So overall, my thoughts on this. A tool like expect is really useful. We didn't even get into some of the cool things that the command line one does, where you can basically run expect in a particular mode that looks like netcat. You're typing back and forth with it, and then when you're done, when you close the connection, it spits out the tickle expect script that does exactly what you just did. That's one of those great nifty things that the expect tool does. And it's used a lot for certain things, like security researchers will sometimes use expect for that very reason. It's like way faster than trying to write it all up by hand. It's just like, okay, make this thing that I just did happen. And as far as I'm concerned, there's no reason why you couldn't do that with Go. Go is, you know, a bigger programming language, but if what you're doing is you want to spit out a sequence of things where everything's done correctly, but it's like an actual Go program that just does what you just did over netcat. There's no reason why Go couldn't do that. A lot of languages probably couldn't do that, but Go probably could do that. And so it's really handy, that kind of a tool. You're not going to use it for everything. So you're not necessarily in your production code. You're not just going to netcat spit out from expect and ship it without looking at it. You know, not a good idea. Not for your production stuff. But it's really good for quickly throwing something together. And because of that, and because of how simple the syntax is when all you're doing is, I expect to see this, I send this, I expect to see this, I send this, and you're not doing anything complicated, tickle expect is probably still a way to go. Because these Go libraries are interesting. They're they look like they could be the beginning of something we could use for something like that. but they're not quite there. Like the user experience certainly doesn't have decades of polish on it like the tickle expect tool does. So for now, if you're doing something really simple, tickle expect is probably still the way to go for that kind of thing. But if you're doing something more complicated and you have to get into actual tickle syntax, at this point, I don't think it's worth learning tickle just to do something 10% more complicated than what you would do, you know, with just a couple of expect, send lines. The syntax gets really weird very quickly when you're dealing with like functions and under what circumstances are strings parsed in which ways, and how do you parse strings how do you send strings which will be parsed at a later time than now, and the scoping works differently. Tickle's syntax gets really different than any of the languages that we're using actively today. It's pretty different from, even if you're very comfortable with Python, even if you're very comfortable with C and Go and Ruby, and you're very comfortable with Haskell and Lisp and like, you know, Erlang, like if you're comfortable with a lot of languages, this is still gonna feel really weird. And so keeping that in mind, I think Go is probably a better choice. Now a lot of this stuff you could do with Go without using something like expect. Like you could just make a reader, and I'm reading this many bytes, and once I see that, then I'm leaving and stuff. But like, that's a really tedious thing to do by hand. And so I think there's still value in a library, a tool like expect or Go that does the tedious parts of that kind of task by hand, automatically for you. So you don't have to go and create a reader that reads the exact number of bytes, but then puts them back in a different kind of buffer before you go and reparse them in a different way, and, you know, all of that kind of stuff. Like, some of these things are really going to be common to so many things in the black box testing world. I think we need an expect library in Go. But on the bright side, like I said, there's reason to think that we're not the only ones who think that. There's a bunch of people who are using these who still have forks that are still making changes to them. So I think there may be a future to this. Right now, it doesn't really exist, I would say, but you know, I guess if I were to try to do something that needed to have a really big black box testing thing tomorrow, something that is beyond just like a handful of lines of tickle expect, I would probably seriously go look at like either the tail scale go expect, or possibly one of these forks of the Netflix one, since the Netflix one pulls like all the spawn logic out and is a little bit more flexible on the parsing side, and then it just kind of leaves all of the like wiring it up to you better. That might work better depending on what the particular problem was. But yeah, I feel like Go is the right language to use for this kind of thing. But maybe we're not quite too early. So that is it, and I'm definitely open to questions. Thank you.
I have a really sort of far off, maybe left field question. I'm totally novice in all this, so forgive me if this is like a stupid one. So I'm here in Austin for the Generative AI Summit.
Yes.
And we spent a lot of time talking about agentic paradigms. And part of the inherent nature of an agentic paradigm is that, you know, these agent models, they're like hitting like a model query a lot to get like the different agents, and it has to be done concurrently. My understanding is that Go is superior for concurrency. So would making an agent framework out of Go make any sense, or would there be or is there like a different sort of like language that would be better for that sort of thing?
Yeah, so Go is very parallelizable in certain senses. Maybe the situation has improved for parallel processes. It used to be not great. I don't know if things have gotten better. For threads, Go is great at that. So it's really easy to do things cleanly in Go. support for things like connecting to a GPU. It's not that Go doesn't have some of that kind of stuff, but there's a lot more people banging their head on it every single day in Python. And so while most of the code is going to run really slow in Python, what parts that are able to export to something like a GPU, the code around that is going to be really well tested in Python. Whereas in Go, it's going to, it'll probably be something officially supported from NVIDIA or something, as Go's a popular enough language or something like that, I would guess.
But there are other features that make Go superior, right? Because like there's security features and robustness features that Go is just better, broadly speaking, than some.
Well, it just depends on what you're comparing it to and in what circumstance. As far as security, and it just depends on what you mean. In this case, one of the things that's really nice about Go is the fact that it is like a statically compiled binary. So once you get it working on a box, it's not going to be a question. You're not going to spend a whole lot of time trying to figure out, well, it worked on this computer. Why didn't it work on this computer? Like, that's going to be less of a problem with Go than with Python or even C or something like that, or C++. But it's also easy to find developers in Go these days. If you're talking about security like versus JavaScript, yeah, one of the problems that the people in the JavaScript world are facing is the kind of this idea that proliferation of dependencies and such, which in some senses is a good problem to have, but on the flip side, it's this. It is a problem that they're working on as a community, but it's a problem that you have to know how to deal with. And so it isn't that Go doesn't have that problem, but they don't have it in the same way or to the same extent. So I think it's just going to depend on the particular circumstances and your access to developers. I think if you had access to developers in whatever language you want, and unlimited funds, and you just wanted to get something that was really fast,
yeah,
Go would probably be a good choice for that. If you had all of that, but then your requirements were more that you were going to do something really, really sophisticated, like math-wise, you're going to do some really complicated equations or something, that would probably be more of a Haskell thing or a Scala thing at that point.
Okay.
If you were going to want to take advantage of really popular tools for big data analysis and things like that, Python is probably a good choice, which is even easier to find developers for Python than for Go, especially for something like that. JavaScript is probably the easiest language to find decent quality developers for. I think there's the number of JavaScript developers who are decent is larger than the number of Python developers who are decent. The number of Python developers who are 101 level is probably larger than the number of JavaScript developers, which is surprising, but it's like, in a sense, there are probably more working JavaScript programmers by a fair margin than there are Python, but there are probably more, I have touched a few lines of code before one time, Python developers than JavaScript developers. So it depends on what your requirements are.
Okay. Thank you.
Are there any like spec libraries in Python, or
in Python, yeah, there are some in Python as well. Yes. I can't think of any. I mean, I in the circumstances where I was needing them, we were. I mean, that's again part of the reason why Go is the obvious choice, is because when you're doing black box testing on the network stuff, there's a very good chance that what you're testing is something you wrote in Go. It's not that you couldn't do that in Python, but by the time you're thinking about things like black box testing, Python was probably not the language that you were Like, it probably wasn't the language you were looking to write whatever it was that you were doing. I would say Python is great for prototyping and for quickly gluing some stuff together. It's not great if what you're trying to do is make code that's really robust in production and it's not going to have problems when you deploy it to 12 different kinds of platforms and things like that. In theory, it's great. In practice, it's not at those kinds of things. Go is really good at that, which is why it's kind of taken off in that world. When you're like, I'm going to go write a custom DNS resolver or something. You could do that in Python, but you would probably do that in Go. It's not that you couldn't do it in Python, it's just that Go probably makes more sense for that. And I think that's where things like this come up, is that Go is probably what you would be writing the kinds of tools that you would want to test these things with. And so that's why it seems like a decent choice. But yes, you could totally do it with a Python version of Expect. I'm pretty sure there are some. But like I said, every time that it has come up, at least for my job, because I have actually used, I know you'll be surprised, I have actually used Expect for my day job.
I used it as well.
Yeah, but usually for Go code, or for interacting with some legacy system. It's one of those two things. That's where it seems to come. I write way more Python code than I do Go code, but I've never had a circumstance where it was like, oh man, like, let's go make sure everything's working right with the Go code because it's going to be deployed in some weird spot and we don't know if we're going to be able to get to it quickly or whatever, something's going weird. Like, Go is what I would use if any of those things was occurring to me. Python is not going to be used if that's the world we're in. On the other hand, if it's just like, let's go quickly glue some stuff together, Python is the choice that more folks on my team would be comfortable with, and so that's what we would use. Yeah.
I think they actually use an Expect, like originally Expect in the Golang infrastructure where like they test the builds. So for example, like if you want to build some really strange operating system, then they may not have like an automated installer where you can just kind of like install it programmatically. So that's kind of like where Expect comes in. You can just spin the QEMU, right, the emulator, and then you can boot just like the regular ISO image, and then you can use the Expect to install the operating system, and then like configure it so that it works as a Golang, like the build bot or whatever, to like do the testing.
Yeah,
They actually use the Expect, the regular TCL Expect, not the Go Expect.
Yeah. It's just funny to think, like, but I'm sure that's another example of if there was a Go Expect that kind of started to emerge as the leader, they probably would switch that, I would imagine. Another thing to point out in the Python world, slightly different circumstance, but you've got like the Jupyter notebooks and stuff like that. And so in some sense there is an overlap between the idea of like, I think only briefly mentioned TK. TK was a graphical toolkit that was originally put on top of Tickle and kind of inspired other ones later like GTK and such. But one of the things that was really popular in the like 90s was combining Expect and TK inside of Tickle. And so there is you can see a thread of that type of thinking in tools like Jupyter Notebooks. And that like, it is a graphical thing that you're looking at, like a web page or whatever, but when you're scrolling through it or whatever, there are code editable chunks. You would go edit those things and it goes and performs operations for you right there. And it could be doing things on remote servers and stuff for you as you're going through this documentation. That is the kind of pattern that first became popular with Tickle and TK with Expect, where they would do things like they would have a graphical pop-up that you would do something and then it would go automate something on some Unix box on the back end. It would ask you questions, it would give you the feedback, it would like translate, the columnar output that you would like parse with awk or something if you were going to do purely command line, and turn it into a graphical thing for you on whatever interface you were looking at. And so you would would have whatever interactions right there inside of the little pop-up. And so there is certainly some, like a through line here to tools like this. But yeah, I guess my thinking is that I think Go is a really good match for expect, just because of where you would use expect for brand new things today. Like there are plenty of legacy reasons why you would want to use expect. But if you're using expect for something new, it seems like there's a greater chance that whatever it was you were doing was Go. At WP Engine, one of the places where I used expect, I was not using Go expect, I was using Tickle expect because I couldn't get any of these things working quite right, and this was several years ago. We were testing that all of our like user interface for a command line tool that we were distributing to customers was working the way that we expected it to. And so we had things like when you type this command wrong, it changes the color. How do you test that on Windows and Linux and Mac OS in your CI/CD pipeline? Like, well, that is a weird, annoying thing. And like, are the instructions on your website the same for all of these things? And like, well, that's kind of weird. But Tickle Expect is great at doing things like that. You're like, the website says you do this, 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 and this in this order. Okay, so I'm gonna open up, like, we're gonna turn on a Windows server at AWS. We're gonna open up a shell, you know, like an old-fashioned shell connection to it, and we're gonna start type inside of the command prompt on a Windows box, and see if when we're done, is there a website running on this Windows box or whatever? And I'm like, and so it was a painful amount of tickle to do that. Tried whenever possible to, like, as I started beating my head against the tickle code, I'm like, okay, let's get some shell scripts, some Python, some Go, calling these tickle things rather than having all this complicated logic inside of the expect script. Like, let's make these things as simple as possible for the expect side. But I don't care, like, if Windows had a new pop-up today that says, like, be sure to, you know, check out our new service that we're selling on Azure or something. It's like inside of the command line prompt on the Windows box. Like, I don't want that to break my test, you know. Like, and so expect is great for that. It's like, yeah, no, just show me this $ thing. Like, oh, we just changed the default colors from dark on light to light on dark. And it's like, okay, well, all the color numbers changed all of a sudden. Like, so now we can't just say, we expect that it is a dark background and then it was light color like this and then it switched back. We can't do that. We have to abstract all that away. But tickle expect is great and things like that. You can say like, oh, we want it to be red. We want it to be a different color than it was to begin with, and we expect it to be a reddish kind of color of some kind. And so we have a special function that says, is this color red? You know, inside of our tickle expect code. And so when we get the code back, we're like, okay, was this thing red? Yes, no. Okay, cool. We basically are embedding that into expect, as we kind of mentioned before here. These weird expect clauses. You got this weird mix of like string literals versus like curly braces, and it's one of those things that you find out in Tickle is that curly braces are actually like sub-functions. So it would be like lambdas, basically. Every time you see curly braces, it's like the equivalent of a lambda that you're declaring. And so that means that every single time you see one, that's what's happening. And so when you're defining a function, it's just a one-liner. It's defining the function as this thing. It's just that the thing that you're defining it to be is the output of this lambda function. And so it's like, okay, well, that's weird. But that made it, like, as weird as the tickle was about that. Like, we were able to make these special implementations of these, like, we expect the color to be red. Okay, that's a special kind of function that we can go create and we can embed that there. But you could do the same thing in Go. Like, that's a concept that would make sense in Go. Like with like this Netflix one, you got like expected strings, and you got like expected, your EOF, and you could have timeouts and stuff like that. But if my memory serves, I think the Netflix one had a way where it's just like a generic template, and so you can be like, I expect this thing to look like this, and it's expecting to read a certain number of bytes. It tells me whether it worked. I expect to get back a string and a collection of strings and all this kind of stuff. Whatever, just like any other Go interface you would implement. And so it's as long as you read these bytes, you return this kind of thing that implements, whatever the pattern is supposed to be, you would be able to use it in a tool like this. And so it's pretty powerful at that point. Like once you start extending, like what do you expect these things to be doing? You could have things like, in this circumstance, I don't care what kind of colors are in the background. I just want to see what the words like this. So wipe out any color data that you're sending back, or like visual bells and stuff like that. ASCII has we're not ASCII, ANSI has all these weird stuff that could just get embedded inside of your text in the terminal. And that's just with ANSI. Once you get into like HTML or something, like now you could have all kinds of stuff going on. So a lot of exposition, that's for sure. But any other questions of any type? Yeah.
In Google, the spec library, I saw there was like channels in the documentation.
Yeah.
Somewhere. Channel. Okay. Arrow.
Yeah. Well, let's just do, yeah. We'll do spawn. Spawn. Okay. So that's returning a pointer to a GEXPECT object. So it's the thing that all of your expect commands run on. It's returning an error and a channel of errors. It's kind of weird. What's happening here is because the expect thing can be just running like in the background and like waiting actively or whatever. You get errors back from each one of these, but I think there are circumstances where where the error came from or when it's coming in can be obscured a little bit. So that's why this channel is here. It was saying, you can get into more details in there, but it's saying, the error channel returns the result of the command spawn when it finishes.
Maybe it's to be error, maybe when command.
Yeah, so if there's errors from the command itself that you ran, then it's going to be some of that kind of stuff. As opposed to the error that's also here. So you've got the error channel, and then you've got this error. And this error is like errors that could have happened when it was trying to do the spawn in the first place. Like things that happen immediately, as opposed to things that took a few seconds before, oh, now it failed. Like, okay. As opposed to all these other commands, which each have an error, but then you can make sure you're not getting it confused with whatever is going on specifically with the top level command. So like if you had a disconnect, that would be an example. So theoretically, you could have something like in your spawn command, it's like you establish a network connection or something, and if you see disconnects, maybe there's something you can do about it, and it preserves this channel or something like that, possibly. Speculating there, but that is the kind of thing that you will see inside complicated tickle expect scripts sometimes, and so it kind of that is certainly where I would expect these things to be. If we're looking at the Netflix one, so you've got a lot more of these like patterns of various kinds appear. We can look at like the expect opt. is like the implied thing that we were doing there inside of our HTTP that we mentioned. You got the top level expect, where we were just expecting the HTTP slash, and then inside of there we were expecting specific codes that came later into the same line. So that's how you would do that with Netflix as well, as you would have this embed. So what is that even? A console callback? I don't actually know. Console callback. Returns a buffer for oh god. Yeah. It is very much like Legos. You get to make your own fun, but you know, it provides it. You got it there. Better than not having it. All right. Well, once again, thanks for coming out. If you've got ideas for talks you would like to give or thinking about it, definitely let me or the other organizer know. A couple of the organizers were out at GopherCon this week, and one of the other organizers was sick this week. And so right now it's just me, but if you're going to the Pound ATX and Slack, the Gopher Slack, we're there. Otherwise, it should be possible to reach any of us. And otherwise we will see you next month. Take as much pizza as you want, and drinks and beers and stuff. I might put some of the drinks and beers back in the fridge, but the pizzas, that's it's not getting any better than tonight. So. Thanks.
Do you have any of the
Shit, we had a bunch last month. We can go talk to Elijah. I mean, yeah. Okay. But we should have one, yeah.
Very cool.
Where should I send folks? Parking validation. Anybody else need parking validation? Just one?
Most people are smarter than me.
That's fair enough.
Depending on where you park, may not be smart.
Hey, it's not unsmart if you get the validation anyway. It's like,
I mean,
there.
well, I mean, like, is street, like, you're not paying for that, are you?
I'm paying, like 5.
Yeah,
Like
okay.
460 or something like that.
I'm paying a lot more for mine, but that's because I live nearby and it's
Yeah.
expensive.
It's $1 grand to live in a shoe closet with a parking space.
Oh, yeah.
I'm sure you live there. Actually, I've been to this place, it's pretty good.
So are you
What
looking
was
for
the-
doing?
East Austin.
No, we're good.
Airport.
Oh.
Like Burleson and 183.
Is the airport north of the river or south of the river?
Typically north.
Oh, okay.
Oh, did you work here? Did you
But
walk
it's like
here or did you
brown.
park?
Oh, I walked. I walked here around here.
Gotcha. Okay.
Okay.
But
right there.
East Austin,
Right there.
South of the river. I like East Austin. Are you near like Central Machine?
Yeah, that's.
Oh yes, thank you so much. Of course.
All right, thanks.
All right, yeah, of course.
The riverfront game.
How'd everything go? That was good.
That went pretty well. Yeah, yeah.
Okay.
Okay, so that's like that's where.
No,
Okay.
we'll,
Yeah, yeah.
Nice.
I may just
Are you
put
I'm in
beers and
Pflugerville
stuff.
right now.
Okay.
We've only got a little bit of pizza left, so that's good.
Hopefully it's
I
not
wasn't
that
sure
bad.
if we should get the same
Traffic
amount, but
slowing
looks like
guys
that was
down
alright.
Yeah, for sure. Awesome.
And then, just moving those two tables back.
Yeah, I know, it's like
We're just
I should just flip a coin of like, should it be 35 or
yeah,
1?
yeah.
I don't know.
Everything all good?
Yeah, I think so. Alright,
Yeah,
thanks.
it's
Good.
I'm doing this thing called like, it's called landing, and it's like you can like pay this like flat fee to like stay in these like
furnished luxury things, and so it's like.
It was a great talk.
Oh, thank you.
So I'm like, I've been doing that since.
I wasn't sure how great it was gonna go, 'cause,
it's on like.
it's been a long time since I've done Go code for my day job, and I was clearly wrong about my assumption when I was seeing like, oh, now there are Go expect ones that are maintained. I'm like, nope.
I think they have actually been changed like since the 2020. I think the last changes were in 2021 for some reason.
Like I had like 3 days.
Yeah.
But it wasn't like,
I get
they
at least 3
did
days notice.
they did
Yes,
this
I
like
got
on,
it. Yeah, basically, like, you know,
Pull request?
so like the
I think there was like some pull requests in 21.
It's also like, I can.
So it looks like they have been updated.
Yeah, I might need to move, especially if it's like
Yeah,
something that's like actually in like Austin.
The Google one
Like,
was,
for example,
I believe,
there's like
and
a
then it
job
was
training
deprecated
software
right after that.
I was able to stay for a little
I think
bit,
that Flix one has also been updated at the same time.